So here we're looking at error intervals when a number's been rounded. So a number's been rounded to the nearest whole number. It ended up as being 196. Write down the error interval for P. So set it up on a number line. They've said it's the nearest whole number. So you've got 196, the number they gave you in the middle. So you go up a whole number and down a whole number on your number line. And then you mark off the exact midpoint between 195, the number you were given, and 197. And those halfway markers, 195.5, 196.5, that bit will get you 1 mark. You've not yet written it technically as an error interval. So the error interval always looks like this, with the P, your X, your Y, whatever it is you want to call it, in the middle, and your inequality on either side. This is saying that P is bigger than and can include this number. It's smaller than this number. That allows for that rounding where you're told that if it's 196.4999999, it would go to a 5. We're not saying we include the 5, so that's why we have the inequality. It doesn't include the 0.5. Okay. What if, though, you had to round to the nearest 10? Again, set up the number line. So this time, another number, 3470. We're going to go up 10 and we're going to go down 10 on our number line. And the actual value you want is the one exactly halfway between the bottom of your number line, the number you've been given, and between the number you've been given and the top of your number line, adding on that 10 if it's been rounded to the nearest 10. So halfway would give us 3465, 3475. So as an error interval, you would just write that as P or X and the inequality either side of these numbers. What if it was rounded to 2 significant figures? So a bit trickier here, because you've got to think about, well, what's a significant figure? In this case, the 6 and 0, they're both significant. So you think about the next significant figure above with 2 significant figures. So the 6 and the 1 both count. And down here, the 5 and the 9 both count. So we go in between 59.5 and 60.5. And again, those 2 numbers would then be written at the error interval with the signs, with the inequalities, like the example up here. So basically, using a number line is a really good way to get this one solved.